This video is part 2 for October 13th and October 14th. We're looking at the inverse trig functions and how they might be used. So let's go over, I'm going to go over these two, and I'm going to show the solutions to 3 and 4 in terms of the triangles. So here we're given the angle theta is here and two sides of the triangle. And if we were to label the sides of the triangle in relation to theta, this side would be our opposite side. This side would be our adjacent side and our hypotenuse. And so we're trying to solve for theta, right? Theta is a function of x. And we're going to do that using the inverse trig functions. Here, theta, we know the adjacent and we know the hypotenuse side. And so because we know adjacent and hypotenuse, really we're going to be using SOHCAHTOA. And since adjacent and hypotenuse, we're going to use cosine. And so what we could write here is cosine of theta is equal to adjacent over hypotenuse, 4 over 5. And now, similar to like solving an equation, think about that like cosine is being applied to theta. We're trying to get theta on its own. So we want to do the inverse of cosine. In order to do that, we just say this is cosine inverse 4 over 5. Or another way we could write this is theta is equal to arc cosine of 4 over 5. We're going to see this on Monday and Tuesday, but if we were to put this into our calculator, that would actually tell us the angle theta. So we have theta on its own, which is what we want, and that's it. Excuse me. Let's go ahead and do number 2. Here we have theta is this angle there. We're given our opposite, we're given adjacent, and we're given the hypotenuse. So it doesn't really matter which function we're going to use because we have all three sides. I'm going to use sine just for the heck of it. We can say that sine of our angle theta, sine is going to be opposite over hypotenuse, so that would be 6 over 10. But we know that that can simplify to 3 over 5. And now similar thing here. Sine is being applied to theta. We need to do the inverse to get theta on its own. So theta is equal to sine inverse of 3 over 5, or theta is arc sine of 3 over 5. Either way, the sine inverse and arc sine is the same thing. Now I already worked out 3 and 4, but I'm going to go ahead and show those solutions and kind of explain what's happening. So 3 and 4, it's the same thing, we just have x values. In this problem we're given the opposite and the adjacent, so we can write tangent of theta as this. Now we want to simplify if possible. Here it'd be tempting to cross out the x's, however this x squared is kind of tied to the 5 through subtraction. It's not a fat one, it's not factored, and so we can't do that. So our solution there would be tangent, and theta is equal to tangent inverse of this. Theta is equal to arctan of that. Similar thing here, we're given the adjacent and the hypotenuse, and so we use cosine and simplify it as that. Now pause if you need to, go back, rewind, whatever you need to. I would also recommend go ahead and do 5, 6, 7, and 8. And if you want me to check those, I can. Honestly, just to give you a heads up, 8, depending on which function you use, because you're given all three sides, you might need to rationalize because you might have a square root in your denominator, so be careful there. Also, here in number 6, once you get a ratio there, you'll be able to simplify that ratio, so be careful when you simplify that fully. If you have questions, email me. Also, check the next video for part 3 for October 13th and 14th.